Good afternoon, everyone. It's great to see a lot of old friends, many of you who were deeply involved in this story we're going to tell today about the last decade or so. Let me start. I think we can see the slides here. Let me start by welcoming up our panelists for today. Donna Rhodes, where are you, Donna? I'm going to spend 15 minutes to introduce some things and then we'll come up. But Dr. Donna Rhodes, Donna is the director of SIRI, that's part of SSRC here at MIT. And as well, she leads our thesis and research seminar and teaches perhaps one of the most popular classes taken by STMers. Eric Rebentis, Dr. Rebentis is also here in SIRI and SSRC at MIT and leads the system engineering modules along with Tom Toner in the STM core. George Lordos, George, where are you? You're here somewhere. Hi, George. So George is a doctoral candidate, but this is his second time back to MIT. And when he first came back from an STM degree. And George was the lead TA in the core for a number of years and was instrumental in the story we're going to tell you today. Professor Devek Ali was, as you mentioned earlier, since 2001 teaching STM, including not only having the role that I have now before, but he led the transformation of the core. Now, I think we began about a decade ago, and we'll get into that a bit. And Bruce Cameron, who's online. Bruce is the director of the System Architecture Lab here at MIT, and he, along with Ed Crowley, lead the system architecture components of the core. We can't proceed without mentioning another empty chair here today. John Helfrich was, he and I are from the same small town. We both were undergrads at MIT and lived in the same undergraduate living group. But we didn't meet each other actually until I came back to MIT many years later. And for those of you who knew John, John was so passionate about teaching. He loved MIT. We lost him far too soon, but we know that John is here today in spirit. So for those later tonight, let's be sure to grab a beer, not a wine, a beer, and toast to John. So to set the ground here, for those of you who've not been back in some time, let me just mention the current curriculum and the current core, and there will be a quiz, okay? So remember, one unit is 1 hour of nominal, targeted, estimated, actual, nominal hours for a 14-week semester. And so the integrated core is 36 units of this degree. We have what were called foundation. We now use the word depth as well as foundation courses, half in engineering, half in management. Electives, 30 units, and a 24-unit thesis for a total of 114 units. Remember that, it'll be in the quiz, okay? But what's today's core? And we'll talk later about where it came from. So the core today is stretched across 9 months. It's 3 classes. But I think when Ed and Tom mentioned the original framing of system architecture, system engineering, and project management, that's still true. But inspired partly, I think, by Unified, we decided this should be more interwoven. So today, across these 15 units in the fall, 6 during IEP, and 15 in the spring, we have a core that for degree students they're taking along with engineering electives and management electives and depth and foundation. And the certificate students, of course, are in the common core with the master students. We know that they do just as well, if not better. We have the evidence of that. And this is an important shift, I think, in testing how to further distance education. Now, we talked earlier about system architecture, system engineering, and program management. And so at the heart of this is that as leaders, we make these decisions simultaneously. They're in trade. Our engineering judgment and our business judgment should not be divorced. And we'll be leading cross-functional teams that stretch across these sets of decisions and how they trade. So we want to both in terms of the principles that were mentioned earlier, These principles of systems apply not only to the artifact, the form, and the function that we're treating. These system principles also apply to the organization and our relationships with stakeholders that we carry forward. We do so by spiraling. We spiral every few weeks across the 3 topics, coming back, building a common foundation, not as well as Ed, but trying to equally frustrate students with ambiguity and cause for thinking differently and understanding that we as leaders have choices. We have choices and we can poke, we can reconsider what convention or even the existing paradigm tells us. One other aspect of the current core as we proceed into the spring is an integrated project that is 4 months long that is now almost completely proposed, topics proposed by non-MIT entities. So companies and government organizations pitching and presenting in January. We typically have 45 or so proposals, and from that, students vote, select, and participate on 20 to 24 teams each year. Okay. Now, how much effort is that, right? This is teaching at other universities, and especially in graduate school. This is asking a lot. We know that. It's a lot of effort. If you do the math, so there's 62 lectures twice a week. That's 124 hours. There are also several workshops that occur, another 32 hours. There are also 60 recitations and a ton of personal work. This adds up to about 504 hours. These are distributed across both SE and PM topics, as well as integrated topics, guests, and cases. And in the end, these 36 units of the 504 hours, about 300 of them are designed to be team-based. So we're rehearsing these skills not only as an individual skill, but as we're rehearsing it, sometimes with frustration as well, with team members who are busy because they're working, they're in a different time zone, and the rest. So you ready for the quiz? Here we go. All right. So this is our enrollment since about 2013, since the start of the story where we shifted the degree somewhat and the timing. Some of you may have been from before the cohort actually now starts in August. So we've aligned with the regular academic year. So this says, for example, in the last few years, we have 130 to 140 students enrolled at any one given time. This does not include, by the way, the certificate students. So how many units do you think STM students take? What courses are the most popular? What courses are they taking? And how are we doing? Because how the students do is also how we all do. So, what do you think? If I only look at graded units that you've completed, not the ones you signed up at the beginning for shopping, not listening, but you actually got a grade for at the end, how many units do you think students take in STM? This is since 2014. Now, this is the total number of units by the time someone leaves. 114 units is shown in the blue line. So the mean here is 136 units. Now, if I showed you the actual graph, there's some outliers of people who are getting dual degrees. I don't know if Garrett's here today. He has like 500 units because he was an undergrad. So take the outliers out, but still 136 graded units. What about listening units? Well, look, during the pandemic, some of you really doubled down. You can have 5 Zooms going at once. So here's the data for listening units, and it's a mean of 31 units. Okay, taken during the time. Question: does being sponsored affect the number of units a student takes? Here's the data, and this now shows a bit of a scatter. The red line is sponsored. So, and if you look at that's a pretty big spread between 100 and 200 units. So we do see a bit of a curve, but what's going on in 2019? Actually, if you're one of these dots down here, you're concerned because you've not earned your degree yet, right? So in fact, some of you are class of 2018, class of 2019 entering, and you've not finished yet. And that's okay. That's part of our, not too much longer, but it's okay. All right. So this is the first part of the story, is that, STM students are special in this special place. Engaged, taking more than they need to take, happily curious. And part of that is the fact that you enter here not yet having an advisor. You enter being able to take classes across the engineering school and management school. That's rare at MIT. So it's a bigger burden in terms of having to figure it out. But in the end, it leads to a really pretty profoundly meaningful engagement with MIT. And so the mean is 165 units of participation for the degree. Okay, next. In the engineering school, here's the courses in MIT, 1 civil, 2 mechanical, and so forth. Engineering school departments. Where do you take classes? Where do STMers take classes? What do you think? Yeah.
6.
Turns out, yes, that's true. But in the last 5 years, STM students have taken classes in every engineering department. Okay, and here's the data. And yes, in fact, Ali, for 16, I gave you the TIE fighter symbol for the graph. I thought you'd appreciate that. But we've seen, and especially with now, some of you who maybe were here 15 years ago, we did have heavy aerospace, heavy automotive. We've seen in the last decade more infrastructure, energy, and health, both in admissions and in engagement while at MIT. Okay, so we're participating across the engineering school. Now, which core courses are the most popular? So I looked at courses that have 15 or more STMers sitting in the course over the last few years. We'll start with the fall term. Okay. What do you think? What do you think, especially if you've not been here recently, whose class do you think it's taken? And yes, Richard Dunafil's still teaching. So this is the fall. From 2018 to 2022, I left out 21 because of the pandemic effect. But I highlighted in colored courses that you could kind of track and follow. And so system dynamics remains popular. Risk and decision analysis, that's Richard Dunafil's class. And we now have the emergence, good word, Ali, emergence for tech road mapping. And if you want to talk to Ali about his sabbatical and not teaching, corner him today. But he promises he'll be back next year for teaching that class. What about the spring? As I mentioned, Donna's System Architecting for Enterprises is a repeatedly popular course with good merit, as well as the other portion of Dunafil's class. The competitive strategy also stands out. Okay, so I don't know if you've not been here in some time, whether this course once. So now we have some reflection on at least what students are taking. And here's another part of the pattern that we've seen and we track, which is other than these top popular classes, how diffuse is participation? And in the last decade, and partly by better advising, we hope, and other things, we're seeing, instead of one person from STM being the only person in a department's class, let's say nuclear or in health, we're now seeing clusters. We're seeing 3 to 5 STMers together taking classes. So it feels like a much healthier engagement across the institute. Ha. Now the grades. What do you think? What do you think our median GPA is? 4, someone said.
What's the scale?
5, it turns out. This is the STM, and this is across other classes at MIT. Okay. Now you might ask, it's because you're giving grades too easily. Now, you know that that's not true, but others might think that, right? So let's dig in a little bit. If I look at the SDM, meaning the EM courses that we're giving grades for, versus classes in the School of Management and Engineering, how do you think our GPAs compare? What's that? It often is, yeah. Certainly compared to some departments. But now that we know that the median's 5, we know that, it's interesting. But this, before I show you the answer, this goes back to the central original mission, which is, this is not an MBA for, slapped on engineers or some technical stuff given to an engineer. We expect students to perform well. And so here we can see this is average, not median, but we can see how they're tracing here. And indeed, School of Management, surprisingly, lower, but they're all, this is all 4.7, 4.8, 4.9. So we participate well, we engage across the institute, and we perform well. So how do we get here? Let me welcome the panel to come up. And I think you're all clipped in. Come on up. And Ali, I do have 5 slides that show 2 work matrices and 3 trait spaces.
Oh God!
From your work. So Ali, let me start with you, and I think I can sit down myself. This is the origin story. So go back to 2010 or so, and tell us. And Bruce is here too. Great. Hey, Bruce, we can see you now. It's great.
Hey, Bruce.
Wasn't it fine before? What was different, and what led to this change?
Well, Ed said earlier, and Tom said earlier, the original design was using our own methods, right? Product development, systematic approach. So we did that too. Starting in 2013, I think Steve and Warren, as the faculty co-directors, really approached us and said, we have indicators that something needs to change. The first thing that really needed to be considered is when the program should start. As you know, in the original design, January was chosen, which is unusual for MIT. Why January? Well, it was because a lot of the students were company sponsored, and a lot of companies said, given the calendar year and the fiscal year and all this, it makes sense for our students to start in January. But more and more students started to be self-sponsored, and that imperative wasn't there, and it was a bit awkward to start in January, completely out of cycle with the rest of MIT. So that was number one. Number two, and I think the question that came earlier about the core maybe wasn't that great, or the core classes were not maybe that great early on in the program, because it was that gap filler, the new stuff that was created to connect engineering and management. So despite continual improvement, there was a sense that there were some inconsistencies in how, system architecture, system engineering, and project management, the way we taught it, there were some inconsistencies in nomenclature, some overlaps in concepts. So we really needed to rethink the core. And probably those 2 were the big ones. And we kicked off a roughly 1-year process of working together, re-interviewing a lot of those original stakeholders, the students, and that's what led us to this process.
As I remember, this is when I just came back part-time, as I was lucky enough to participate in these sessions, including we had a retreat out at Endicott House, and we invited alums and industry folk as well to participate. One of the things that shocked me as a non-academic kind of coming into this was this talk of learning objectives, and how these learning objectives, we spend time to recraft them, reconsider them, and then use them somehow in the design. Can you comment a little bit on that?
Yeah, sure. So in the 3 areas, system architecture, system engineering, project management, we kind of pulled together the learning objectives that were there, but we enriched them. We made sure they were, and then we went out and surveyed, which of these are the most important ones. And some interesting things came out. For example, in project management, which you know very well, one of the top objectives was the ability to go back and challenge management on unrealistic expectations for scope, schedule, and cost, the iron triangle, but the ability to credibly go back and challenge unrealistic project targets. That came out as one of the top learning objectives. And it wasn't, not that we didn't know about it, but now it was explicit, right? It was in front of us, it was quantified, and that was very helpful.
Great, thanks. Let me turn to Eric and Bruce for a second. So I think maybe you were kind of rolling on about the same time I was here, and kind of observing what had been taught in the past and what was coming up. Can you comment on, for the areas you've been involved in, not only in 2013, 2014, as we were making these changes, but more recently, what's changed? What was this transformation about, and how did it affect the way that the topic is being considered and taught? Bruce, can we start with you?
Sure. So I'm so pleased to see you guys all there, and I'm so sad that I'm not there in person with you all. My apologies. We have a newborn at home, so we're being extra careful. This is my 11th year teaching in SDM. And two of the things that sort of stick out to me that have really sort of transformed how we run are, one, the projects. I think the quality of the spring projects, many of which, the instructor team, Brian, you in particular, have sort of brought a number of them in to work on really challenging projects. I think it's really served as an interesting substrate to work on, but has also served a whole bunch of the integration tasks that we, the instructors, couldn't do individually, right? It's something that we all share through the core, and the student teams get to work on. So, just as a couple examples of that, there was a project 2 years ago that was Telesat, one of the big, low Earth orbit satellite providers, looking at what are some of the other use cases for these massive networks that we're putting up. And there was a student team who worked that for 4 months. Now, they had the opportunity to look at the sort of system architecture dimension of that problem, and then systems engineering, and then project management. I think it serves a fascinating sort of integration function. One of the ones we have this year is very topical, looking at wiring loom supply chain challenges from Yazaki. Interestingly, a domestic as well as an international component of that project. So I think that's really quite transformed over time how we sort of think about and teach to the core. And the second that I'll just mention briefly is, the world of sort of synchronous online education is a world that SDM really pioneered. And now we're seeing the rise of sort of asynchronous as well. And many of the folks here in the room have participated in a variety of different experiments that MIT has run. One of the experiments we did with the SDM core was doing an asynchronous component to system architecture before the onset of the fall, as a way to give people an opportunity to get up to speed should they so choose. And I think that's really worked out wonderfully. I think a lot of people have been sort of eager to join that, and it's given us an opportunity to change how we think about teaching, and to center in some ways more around discussion than around content once we get going. So, Eric, I'll hand it over to you.
Thanks, Bruce. So I was involved in the core redesign team, and just as an invited guest, I guess. And then in August of 2017, you showed up in my office and said, "Hey, Eric, how would you like to teach STM systems engineering in the core?" And I should have said no and get out, but I didn't. And so I've been riding this train ever since. And what's one of the things that was happening at the same time that I started was I was finishing up leading up a book effort on integrating program management and systems engineering. We identified a number of activities that in a program you would engage in infrastructure tools and so forth to get engineering and program management teams to work together more closely. And so Bruce mentioned the team project being an important integrative element. I think just the fact that we are all teaching in the same room in the same semester or for 3 semesters is really important, because systems engineering happens in the middle of the sequence: system architecting first, systems engineering, the program, project management. And I got a chance to look at what Bruce and Ed are talking about and teaching, and whether it matches up with systems engineering concepts. And then I get to look at Brian, and Brian often gives me feedback of, well, you talked about something in my lecture, so stop it. So just the fact that we are adjacent and meeting on a weekly basis, I think has improved the quality. And then we have this relentless drive for continuous improvement. We have annual meetings with all the scores. We review all of the grades together, talk about how are students doing. And that kind of feedback is really important for this continuous improvement process. In systems engineering specifically, I've been changing the content at least 25, sometimes as much as 50% every year. And I'm not done yet, just because there's so much to do. And with the work that research projects that Ollie and Donna and I are doing collaboratively, it's feeding into the content.
And I couldn't agree more. In project management, there are things I can teach because so many core principles have already been teed up. And some of the hard work of asking people to understand abstraction and interfaces and other things now that I can bring into project management has changed fundamentally how we teach project management. And I would not have been stimulated to do that had I not been part of this team. Now we'll come back in a little bit to the continuous improvement process, but coming back to this shift, this fundamental change before 2013, 2014, and after in the integrated core. Let me ask Donna and then Ollie, as now wearing a different hat, downstream recipients. So you work with STM students in your classes and in theses and research. Any indication that that this has had a change on the readiness of students or capabilities? Donna?
Yeah, I think absolutely. I mean, I've been around for STM pretty much since the start in one role or another, and I think that early on, the lack of the year-long core made it seem more modular, and I think that with the year-long program and trying to cycle through and iterate, that's made a huge difference. And I believe too, I teach my class on systems architecting applied to enterprises in the spring semester. And so the luxury that I have is to be able to build on the things that they learn in systems architecting and all of the modules in the core, and use that as a springboard for where I go with my class. So I think that there's a power to help each other. We keep each other informed, I think, about what is going on in our classes and create synergies around that.
Yeah, I absolutely see the benefits downstream, not only in the classroom, but also for thesis research. And we haven't really talked much about the companies that have stuck with STM for many years, who've sent students, employees, and they've gone back to the company. But a couple of them I'd like to mention, because the students associated with those companies and the program, I really see the progression and the transformation they have been doing in their companies. One is John Deere. As you know, John Deere has been a big supporter of STM for many years. I've probably supervised or co-supervised maybe half a dozen John Deere students in their thesis. And it's really amazing how, you think John Deere, oh, it's a tractor company. No, it's a systems company now. Agriculture has become very high tech. And the quality of the students from John Deere and the theses they're doing, how they're applying all the concepts from the core, decomposition, network theory, system optimization in a really real world context is impressive. And so I think it'd be great to have somebody here from John Deere to confirm that, yes, STM has really helped transform the company, but I think it has, from my vantage point. And then more recently, Chevron, of course, the Chevron Digital Fellows, a couple of recent theses, Chevron is, in the whole industry, of course, is transforming and digitizing especially. So topics like digital twins, offshore platforms becoming less people intensive, more automated, safer, huge progress. And I think the progression of the students when they arrive, the boot camp, the core, the other classes, and then culminating in a thesis for the degree students that is really transformative in their companies. That I'm not sure we saw quite to that extent until about
I couldn't agree more that
Yeah.
we're seeing more and more of those threads.
Yeah.
And also starting companies, projects that have become a startup as well. So I'd like to shift the conversation. And by the way, there is no clock in this room anymore. So if you can signal once in a while, I have no idea what time it is. You know me, I talk a long time. So I want to shift to continuous improvement. So we made this change 10 years ago. And there's two kinds of ways we confront that. One is in the summers. There's this significant annual review that Eric mentioned. And also we as a team, we do improvement every week. We'll talk about both of those. But first, if you in this room have been involved in the summer annual review of the core, please stand up. Okay.
Wow.
So I got an email, actually a great email from a student last week with some suggestions, which were good suggestions, but I made the point in response that this is part of who we are. And especially the students having a deep responsibility to be involved as part of the instruction team to make changes. And that's why I wanted to make sure, George, you're on this panel. So can you, from your point of view, because you were a student and then head TA for many years, and you helped significantly us to understand how to deliver this complicated core better. What is the summer annual review, and how does it operate, and how does it function?
Well, I would say that the summer annual review is like the slow feedback loop in this autonomous self-improving learning system that is SDM. And the TAs are the fast feedback loop. So in this summer annual review, it's everybody's around the table as an equal. So the directors, the faculty, the program office, the TAs, and students as well. And we generally do three things. We look at what we had planned to do for the year. What did we actually do? So we get data and we do analysis on that data. We read carefully the scores and the qualitative comments on the student evaluations and take them into account. And then we also listen to the voice of the students and the TAs. And I would say the students and the TAs are one. I mean, the TAs are all students, and the students then become TAs in their second year. So with that information and discussion, the group then decides what is the emphasis and what incremental changes should be made in the next year. And this happens each year. So it is really truly a continuous improvement process, as Ed had said earlier. Yeah. So
Well, and I think the other part of that is that it's evidence-based, and being properly evidence-based, it's a lot of effort. So for those of you who stood up, there's weeks of preparation and gathering thousands and thousands of points of data on, did we teach what we thought we were going to teach? What did we actually, in the end, spend time on? For the readings we have and the cases that we teach, is it representative across the different domains of complex systems? And on and on and on. And it's still there. My mic is out. It's on? All right. No better. It's less feedback. So it's a lot of effort. How does that compare then to the small feedback loop? So how would you describe, because I apologized to who was it yesterday I met, and I apologized because they were in the first year of the integrated core. Because there were a lot of rough, there were some things we were still figuring out. But let me turn to Bruce for a second, because Bruce, you're part of we meet weekly, right? We meet as a team every week. How would you describe what the importance of that is to being an instructor and how it has led you to maybe make adjustments on the way?
Well, I think, particularly during COVID, trying to adapt and sort of meet the team where we are, in a sense. There was an awful lot of coordination for those of you that weren't here during that year that went on trying to figure out how do we do this all remotely, sort of like trying to fight with one arm tied behind your back in some sense. I think what we're watching as an instructor team is sort of how many of these messages are landing and not landing, in the sense of, this has become not a broadcast mode, but a discussion. We're trying to figure out sort of what's working and what's not working. And among other things, the weekly coordination meetings give us an opportunity to sort of hear from the current TAs who have their ear to the ground on sort of what has worked. That was one of the great travesties, I think, of the year that we all spent in our homes teaching remotely, is you can't watch people's faces. And to me, being able to sort of watch everybody's face in the room is just such a big indicator of sort of how the discussion is progressing.
Thank you, Bruce, and I come back. By the way, for those who are current students, there'll be a note out shortly if you're interested in being a TA next year. And there's summer work available because we'll do this again this summer. So please participate. Well, let's now shift the conversation to beyond the core and new course development, and also where you think the core may be going. But let's start with courses. So Donna, you and I were talking, your course has been taught for some time, but it really is, has it evolved? If I think about the number of new courses we have, your course still, though, stands in the center of their STM specific courses, I think. So how's it evolved?
Oh, it's evolved a lot to the point where I feel like it's a new course every year I teach it, because I think especially in recent years, if you look at enterprises, it used to be fairly stable enterprises undergoing things like lean transformation or just basic improvement. But now we have so many disruptive factors affecting enterprises. Enterprises are not just corporations anymore. The way venture funds are run is different, the number of startups and so forth. So I feel like I try very hard to incorporate things even from the morning's Boston Globe into the course, because I believe that, and this is, I think, part of what this whole program has been about over time, is that the larger ecosystem is such a huge factor in our ability to not just take that as a constraint, but to be able to think of the ecosystem as something that we can influence, we can leverage. So I try to build much of that much more into my class now than I used to, as far as that goes.
And are we going to be able to convince you and Eric to do a new class on model-based? Is that a yes? I heard a yes. Good. But that's part of it, right? I mean, we constantly reinventing. Let me give a few other examples.
Yeah.
Where's Warren? So Warren and I are just piloting a new course on software engineering projects, which is a pilot, but we're trying. We're evolving. Ali, you have the new tech road mapping course, which is an excellent course. Rumors you might be redoing MDO a bit, or that's a class that's been around some time, but you're thinking about evolving it?
Yep. So I talked about tech road mapping, which will be offered again in 2023. What I've seen there, MIT's really changed in those 20 years as well. Half of MIT, maybe this is slight exaggeration, is life sciences now, right? Moderna is right over here. So the amount of technology, the Broad Institute, the amount of technology that we see in the life sciences, broadly construed, is enormous. Huge opportunity. And so how to accommodate more life science technologies in that course is a big challenge. Got to think about that. And then the way I think about it, technologies are like bricks, but systems are combinations of technologies that need to be combined in an optimal fashion to get to the desired result. That's the MDO class in the spring, multidisciplinary design optimization. And there, things have changed as well. A lot of computation is done on the cloud now, right? Cloud computing, MIT has the super cloud available, different algorithms, machine learning now, training models instead of building them from governing equations. There's so much going on that, that we need to reflect in these courses.
A lot of these advanced elective classes are things that we couldn't fit into the core, or they're natural extensions of the core. I've had the chance, for the same reason, students asked for it, and it seemed to be the next step. So there's 2 new classes that I put together, one in the fall, which is a class on engineering teamwork. And it's a research papers-based class, and it has some ethnography, a lot of social science, but also a lot of experimental research papers on engineering teamwork. And then in the spring, there's a class, which is a lab class on building agent-based models and building agent-based models from scratch. So hopefully we'll continue to see, Bruce, I'm looking at you too, continue to think about how we can contribute to the future cohorts through evolving it. Well, as we've only got a few minutes left, says Joan, so let me open the floor for questions about the curriculum and the core especially. So please just stand up and we'll point at you. Is there a roving mic here anywhere?
I don't know if we do, but we can always repeat the question.
Okay, very good. Yes, please.
Hi, so this is Sridhar from 2016 cohort. Just a quick question. I mean, a lot of alumni are here. Really appreciate the fact that the core is undergoing a continuous process improvement. Just wanted to understand, how can alumni take the advantage of the improving core content in being able to keep refreshing what knowledge they have, and take advantage of the fact that, hey, we have been in SDM at different points of time, systems are changing, processes are changing. How can that connect?
So the question is, how can alum benefit from the evolution of the courses? Well, let me turn to Bruce, because this is a good segue to. Oh, no, I'm serious. But no, this is so there are. One of the things from the very beginning about this program is that we're called in our mission to find new ways to serve working professionals and to connect to industry. And so getting the degree is maybe the heart of this, but there's a lot of other forms. And so so Bruce mentioned kind of the success of the classes that you've done online and the huge numbers. And in fact, Steve Eppinger and I are just launching a new 3-course sequence as well in technical project management. So those courses are a chance. But Bruce, how many people have you trained at this point with these online classes?
I feel like I'm a phone a friend here, Brian.
I think it's pretty clear that you do have the highest number of attendees in your online courses, so that's why.
Well, okay, I'll be a lifeline. I think, to the gentleman's question on participation, I think the projects have been a huge and just wonderful boon as an opportunity for continuous engagement with the alumni. So, to the extent that you're working a problem at work that you think could be worked by a student group, or you've got future concepts that you can't get to or don't have bandwidth for, we've seen a whole bunch of these come in from the alumni. Like, the alumni are the big strength. There's a lot of corporate partners who are sort of floating around MIT looking for points of engagement, and it's also served as a great way to build new relationships in that sense. But that's a really big one, because then you get the joy that all of us on the stage here get, which is the engagement with the current set of students and working hard problems. So yeah, I think the other way in this is that MIT is seeing an explosion of new courses, and there's always opportunities to sort of help co-develop. Dan Adsett, SDM 13, and Andy Friedel, among many, have been instrumental in building folks with me. Similarly, we have actually a former and current SDM, somebody who graduated with their certificate and then has chosen to opt into the master's program that Ollie and I have been working with for the past 6 months on a brand new course on two-sided markets. How do we design a market and what are the technical challenges that underlie something like building up an exchange like Etsy or like Uber.
Great. Thank you, Bruce. And on this question, any quick comments? I would say that we do things all the time. We're doing workshops for companies and.
But I would say let's take this as homework. This is a challenge. I don't think we have it fully figured out.
Very good.
And so we'll come back to you.
Well, we've got a break. Oh, you have an online question?
One online question. and
Sure.
I'd just love to give an online person a chance. And just the comment was, do we have current research focused on nonprofit and government organizations? How do we think about driving innovation and organizational performance when bottom line is not the motivation?
Well, I think I deal with that in my class. It's a projects-based class, and I let students bring in ideas for what they want to pursue. And we've had a number of projects of that nature. I think it's extremely important because we really learn a lot about the differences between what happens and the kinds of approaches you can take when you're under that situation of nonprofit or serving societal value. But I think more and more, even larger corporations are starting to find that they have a piece of their corporation that might be a foundation or some other kind of not-for-profit entity that they incorporate or spin off or have a kind of tethered to it. So I believe that no matter what kind of government agency, company, or whatever you're working in, that you're very likely to have to make decisions concerning some kind of not-for-profit piece of that.
And let me add, we continue to see in admissions and in participation, government employees. And, we teach n-dimensional thinking, right, and reasoning. And even in the private sector, as you said, sustainability alone gets us far beyond sorry, Ali, a single-dimensional optimization of NPV. So with that, I think we're going to transition here. Let me just make one quick plug that there'll be a conference this summer that we're holding here, an academic conference called TE, Transdisciplinary Engineering, on the future of engineering. It'll be here July 5th to July 8th. Ali's one of the keynote speakers, but we're now reviewing 110 full papers we've received on engineering education, engineering research, and engineering practice. So if you want to come back again, please come this summer. So with that, please let's thank the panelists and continue the conversation during the break.